to the lecture series in computer science on principles of deep learning. In today's session, we are going to focus on loss functions. In previous sessions, we come across the various factors that contributes to the performance of any deep learning model. In today's session, we are going to focus on loss function, the various types of loss functions that can be applied to various deep learning models, and how the Python libraries can be used to implement it. Moving on to the exact definition of a loss function is also known as a cost function or an error function under deep learning. It actually do the difference between, or it quantifies the discrepancy between the predicted value and the actual target value. This is the main role of loss functions. While we are evaluating the model, we have to just consider how the outputs, how the factors like what are the different input weightage has to be given for various parameters such that we can minimize this error function. Any model that is being evaluated, we have to first think about how the error can be minimized such that the input weightage for each of the parameters has to be balanced. And now moving on to a role of a loss function, we see that the loss functions are the error measurement. It actually does this the gap between the actual and the target values. Moving on to the next one, it guides the learning process and it is actually depend upon the various tasks that has been given. Moving on to the last one, it controls the model behavior depending upon the speed, stability and the generalization. Moving on to the timeline, when the loss functions has initially been developed, less than in 1950s, the actual functions, error functions like the mean square error function and the mean LE functions have been developed in late 1950s, early 1950s, and in between 50s to 80 we got loss functions like cross entropy and the log function. And in mid 80s and 90s we come across the mean square error for the neural networks. In case of 1990, we got hinge loss and the adversarial losses. These are the various kinds of losses that has been developed by various authors during the course of the model performance. And in 2000, it is focused on the focal loss and the smooth L1 loss. In case of 2010, it is focused on the style and the content loss, and now in 2020s there are various types of losses called the perpetual loss, total variation loss and the feature matching loss. And these losses are the different kinds of losses that can be applied to any of the deep learning model, and these functions can be known with exact definition in the subsequent slides. Now moving on to a deep learning model. What are the different problems that can be solved in deep learning? We have already discussed. There are various kinds of data handling methodologies, like the data can be handled in tabular format, or there can be a prediction of the future like time series data which is feed online, and there can be a processing of different kinds of images or the videos. Now with these different kinds of data, we come across the object detection model or object tracking model or the motion detected model or image implanting, or there can be audio to image conversion or text to image generation. So these are the various kinds of applications that we work on. So for each of these applications, the type of loss functions that can be applied cannot be similar. Depending upon the problem, we have to change the loss function such that what type of loss function can be applied to which type of application we have to get through. So moving on to the exact different types of loss functions. First one is the mean bias error, mean absolute error, mean squared error, root mean square error, Huber loss and log crash loss. So if you see these different kinds of loss functions, we come across exactly what it does and what is the mathematical equations to represent these loss functions. Now moving on to the mean bias error. So here this actually captures the average bias in the prediction. So it actually does the difference between the targeted value and the calculated value, that is the actual value and the predicted value. So, the exact difference is being taken and it has been averaged over here. So, if you see it is 1 by n sigma of y minus f x. Now, moving on to the absolute error. As the name itself gives us, it actually covers the errors that are the absolute average values of the given input data, and it is also called as L1 loss function. Here a little bit variation between the previous function and this function is the absolute value is being considered while we are calculating the error value. Now, with respect to mean square error, the name itself giving us we need to square the error difference value. So, here this one it is actually squared, the distance is being squared. See here y minus f x and their difference is being squared. So, in this way different authors has proposed different kinds of error functions, and these each and every functions can be applied only to different types of applications. Now, root mean square error, and the word itself is giving the mirror meaning that it is the square root. So, it is y minus f x whole square whole to the power of root. Okay. Now, Huber loss, and this is the combination of two error functions like the square error and the absolute error. Now, if you see here the values is being defined like y minus f x whole square value is given and absolute value also being given depending upon how we are taking the delta value over here. So, it is a combination of both. And last one log crash or loss values, it is similar to Huber loss method, and there is computationally this is little bit expensive, and we are calculating here some non-parametric values has been added to this. And now moving on to the other methods. In previous session we seen that these are all the different methods which are applicable for the regression losses. Now, we will see the loss functions that can be applicable to the classification problems or classification losses, which can be applied either to a binary class or a multi-class. Now, moving on to the binary cross entropy method, this is mainly for the binary classification task. This loss function has to be applied, and the formula to calculate the loss function is being given over here. It is the sum of the summation of the y into log of p of x plus y 1 minus yi into log 1 minus p x. So, here these functions mathematically these have been implemented in Python libraries, and whenever we are using this in our particular application we need to apply the exact built-in function that was developed already. Now, with respect to the hinge loss, this penalizes the wrong and the right. The variation is between the maximum value of the 0 or 1 minus the functionally calculated value. So, this is very commonly used in support vector machines, and there is one more called the cross entropy loss method, and this method is applied to the multi-class functions, and the formula for calculating is given by minus of 1 by n sigma of y into log f of x values, and here n stands for the sample and m stands for the classes. Now, moving on to the last type, KL divergence method. This actually minimizes the divergence between the predicted and the true probability distribution. And all these formulas there is no need to by heart, because in our Python libraries we had already, we will be using the exact built-in function in our applications. Now, here moving on to the exact definition what it does, we come across various various types of loss functions. Now, how this each of the loss functions which are being used for image classification. So, if you take applications where image is being segregated or classified, we can use all these functions. Just remember, you can apply either the Euclidean loss method, or you can apply cross entropy loss method, or you can do attention target loss, ranking loss, and Kullback-Leibler loss. So, moving on to the exact definition, how this can be applied. So, when there is you wish to have the errors, you want to square the difference between the predicted and the actual output values, this is commonly used Euclidean loss, and this is mainly used in the regression problems. And this cross entropy methods is actually assess the difference between the predicted probability and the actual case levels, and these are very much applicable for the classification problems. Even in image classification problems these methods can be applied. And when we see the attention target loss method, this mainly focuses the classifications on relevant regions in the input. They consider only some parts of the input where we want to focus on those things, and it mainly guides the entire network to emphasize the important features. Now, ranking loss methods, it actually evaluates the relative order of the classes. And we move on to the next method called how these loss functions can be applied in the object detection applications. Now, we come across already this cross entropy is being used in the previous methods also. Now, we see the other one which is not yet covered is the mean square error method, and here actually the average, the difference is being squared with respect to the predicted and the actual values, and this is mainly used when you are including a regression model. Now, the other important loss functions out of these is the smooth L1 loss function. Here we combine L1 and L2 characteristics, both of them is being combined, and it is less sensitive to the outliers and than in the mean square error method. So, it actually stabilizes the bounding box regression methodology. And moving on to the focal loss method, and this is a very much simple variant of the cross entropy method, and it hardly very harder to classify the examples. It actually have the class imbalance, it is usually it addresses the problems of the class imbalances. And moving on to the other functions, loss functions that can be applied in the regression and the semantic segmentation. So, there might be problems in real world which falls under this category. So, for those things you can very well apply the cross entropy loss method and the contrastive loss method, and these actually mainly calculates the difference between the predicted probability and the actual labeling. Now, when we see about the semantic segmentation methodology, you can very well apply either binary cross entropy or a cross entropy, or you can do very well the pixel wise softmax cross entropy methodologies. So, if you see a pixel max entropy method, it combines the softmax for normalization with cross entropy, and it is mainly used for the multi-class segmentation. So, depending upon our problem, we have to choose our error function such that the error function is being minimized. How much weightage can be given to each of the input parameters? You have to calculate the error function, and whichever function gives the less value or a reduced error value, we have to apply to our function model. So, here we got till now we have seen many different loss functions. Again, once again, some of the major features of a particular loss function we will just discuss. So, we know that MSE stands for the mean square error methodology, and when you consider these two, reconstruction loss function and the adversarial loss function, they actually assess how well the generated image matches with the input information. So, if you see the image classification methodologies or object detection methodologies, here text to image generation, or whenever some piece of text has been given, the system itself is generating an image for you. In these cases, the loss function that has to be applied is the reconstruction loss. So, here it just discusses or it focuses on how the image matches with the required input. Now, adversarial loss methodology here, it challenges the generator to produce the realistic image by evaluating the output against those of the discriminator method. So, these are the some of the methodologies which can be applied to any of the text to image conversion applications or the adversarial applications. Now, moving on to the other things which are very popular nowadays, you can even see you want to calculate the noise, you want to predict how much noise occurs in our particular model, you can focus on this. Here it focuses on predicting and minimizing the noise that has been in the output. That means, it improves the quality of the final image, and you can even go for the diffusion loss. Here it relates to the diffusion processes, whereby it mainly gives the difference between the image outputs in various steps as a progressive refinement. That means, it generates the images in a step by step way, and progressively the quality of the image can be refined over. So, these are the various things, and we can go through one more methodology also. See the conditional adversarial loss. Here also, here the generator, it guides the generator by conditioning, it gives extra condition or an extra information such as the class labels to provide the relevant images to the context. So, these are the various loss functions we have. Now, out of all these loss functions, whichever loss function can be applied to what are the different real world applications, we can have a gist over here in this particular diagram. See here, when you take a image classification methodology, you can go for either cross entropy method or MSC method, or you can go for the attention ranking, etc. Now, when our application is about the object detection, you are mainly focusing on how you are going to detect a particular image. You can very well apply binary cross entropy methods. The other methods are similar to that only. Here you will get the better model performance. You can use focal loss method or the efficient IOU methods. Now, action recognition method, here some part of movement is being recognized and you can very well go for the contrastive loss function. Now, with respect to object tracking, you can even go for the smooth L1 function or soft max function, and in semantic segmentation problems you can very well go for pixel wise cross entropy methods. There are various methods, and depending upon the how well the there is a reduction in the error level, we can choose that methodology. And here these are the different applications which targets on the descriptive talks methods. Here image to image generations might be there, or a text to image generation applications can be there, or in audio to image generation applications can be there, or even image inpainting or image dehancing methodologies are applicable. So, out of this adversarial contrastive comes under image to image generation, and here you can have the categorical cross entropy or perpetual in case of the text to image generation, or you can even go for reconstruction loss function when it is between audio to image, and you can even go for style or the feature matching methods in case of the image inpainting. In case of image dehancing, you can go for smooth LL or adversarial. So, these are the different loss functions which are applied to various functions. Now, we are in a stage of what are the different kinds of loss functions that are available. Now, we can see what is the actual advantages of loss functions in any deep learning model, or there might be a little difference or the disadvantage with respect to applying any of the loss functions. So, each and every methodology, what is the merit and demerit, we can just go through over here. When you take a cross entropy method, it very well suited for multi-class, and the only thing we can just see about it is class imbalance. It is very sensitive to the class imbalance. And moving on to the binary cross entropy method, you can very well see it as there will be a clear probabilistic outputs will be there when you apply this, and here it may not be well with the correlated data. It may not perform well with the correlated data over here, and sometimes the outputs are independent of the values. And when you see the L1 loss method, it is very much robust to outliers. You can very well take this method, and it always has a less smooth convergence during the optimization methodologies. And if you take a focal loss methodology, here it addresses the class imbalance very much, and here it is very computationally demanding, high amount of computational power it requires. Also, it requires the tuning of the focusing different parameters. And other methodologies we can see is the PW soft methodology. Here in this methodology is very effective for the segmentation, and as a disadvantage we can say high memory requirements or high computational power is being required for this methodologies. Now, moving on to the other methods we come across for all the image oriented applications, adversarial loss method is very important, and it actually enhances the generated images very much. The disadvantage we can think as it can lead to sometimes instability, and this categorical cross entropy method, it is very much applicable to the multi-class problems, and actually it raises some of the class imbalances. And moving on to the perpetual loss method, it captures actually the difference, and it is very much been usual for visually appealing results, but the main disadvantage we can see it is very expensive to the future extraction. And when we move on, how this each of the functions can be applied in any real world applications. We have mathematically equations for all we have seen in our previous slides. Now, we can very well understand in what are the different real world applications these have been used. One is with when you take the mean square, it is very well applicable to when you are doing some prediction with respect to the electricity consumption based on some past information, or very well you can forecast the temperature trends in weather prediction, or you can even go in a supply chain management for an estimation of a demand. When we move on to the absolute error methodologies, this can be applied when you want to predict something, the delivery times in case of a logistic, or you want to predict a traffic flow with respect to any particular region, or even you can predict the income levels. So, these are the different real world applications for using these loss functions. And binary cross entropy method, this can be very much applicable to medical diagnosis, whereby you will predict the disease presence or not, and even it can be applied to the credit card fraud detection or customer churn prediction. So, these are the different applications where we can apply this loss functions. Even the categorical cross entropy method can be very much applied to the hand recognition or the speech recognition applications. They are very well versed with the language translation applications by predicting the correct word from the vocabulary. And even when you come to Huber laws, this can be applied very much in applications like autonomous driving, robotic, or the stock market trend prediction. So, in these, when you are dealing with the data sets of these kinds of applications, we have to think that this particular error function gives a better performance than the other things. Now, moving on to the how this can be implemented using the Python libraries. We have very well all the libraries, all built-in libraries for all of these loss functions. There is a built-in function nomenclature. We should just understand how to utilize this in each of the code. So, this is a simple example. This is not of a data set kind. We have taken the values and how this method should be called. Here our intention is by what name we will call this built-in function such that it gives us the required loss function or the error value. See here, these are the three import statements where you will import the Python libraries for the torch package, and here a data set has been taken over here. This consists of house size in 1000 square feet. So, size of the house is being given and the label stands for price are lakhs. So, two different kinds of parameters have been taken over here. X represents the house size, Y represents its price in lakhs. Suppose if we take the data like this and you are calling a linear regression model, you will get a graph fitting the x and y values. Now, we need to compute the the MSE loss. So, the function that is used is the nn dot. Nn is the variable name we have taken over here as the torch function, torch built-in package, and here MSE stands for the mean square error. That particular built-in function helps us to calculate the mean square error for the given data. So, after it is been calculated, you are going through the model optimizer and then you are using a loop to calculate the loss values. So, once it is everything is done, the calculation is done by the particular turning or iterating process, the final loss is being depicted and predicted prices have been displayed. So, this particular code helps us to understand how the built-in function of the mean square error is being calculated. Now, moving to the second example of absolute error, what is the nomenclature we use to call this function? We have to understand it is L1 loss function. So, depending upon for the previous program, here again the linear model is considered and then the example is the mean square absolute error value, mean absolute error value, and again some optimizers being applied. Here we have to understand that this Adam method or the previous model SDG method, they stands for different descendant methodologies, and these different methodologies we will discuss in our next forthcoming sessions. And here in each of the things loss has been calculated in each of the phases and overall loss has been predicted or calculated as the output value. Now, moving on to the third example, it is about the binary cross entropy methodology, whereby input values is being given with respect to word is present or not and how well the words are, whether they are spam words or not. So, the percentage value has been given, sensor network package has been taken in x and y, and as usual we are applying a linear model for this, and it is a sequential model also, and the binary cross entropy methodology is being called with a function called BCE loss. So, after this methodology is being called, again some optimization methodology or a function is being fine tuned the performance, and for each of the oppose, for each every execution, here we are calculating the gradient, and then we are giving the output values, model output values to output variable over here, and all the loss functions are being defined with the given criteria, and the final loss value will be there in the loss dot item variable, and this also predicts the probabilities by which the model is being detached and it is being squeezed. So, this particular program gives us how a binary cross entropy can be applied to a given data set. Now, moving on to the multi-class functions. Here we take a sample of 3 classes, 3 different kinds has been given over here. Their true classes have been has been applied in a TensorFlow grid network, and you are calling the linear model, and the methodology that is used to call the loss function is the cross entropy loss method, and here again you are calling a gradient and you are applying or calculating the loss for each and every we can say it is a phase. So, loss has been calculated, loss has been made a backward step, and here you are calculating the final cross entropy that is considered in loss dot item value, and predicted values has also been displayed. So, this methodology is being applied for a multi-class problem, and that too with respect to the example is being taken such that you are taking 3 different classes. Now, when you move on to the Huber method, here a sample data set is being taken, but one of the values with higher probability values. Prices remains the same, only there is one change in the probability value. So, this is a linear model, and you can apply L1 loss methodology for this. You have called some gradient descendant methodologies, oppose have been calculated as usual, and errors has been displayed over. So, if you gone through the previous all the examples, we are very clear that for all the examples we have taken only one input, and we have called the linear regression model only, and we applied only the changes how we are calling the loss function and which gradient descendant method has been applied to that. After this epoch, this iteration in the for loop remains the same for each and every program, and the final loss value is being computed. So, by this we came to a conclusion that how these loss functions have been used in deep learning models. We have studied various kinds of loss models, and these loss models actually helps us to improve the quality of the performance of the model. So, we know that for each of the different applications one particular loss functions can be applied, and how these Python libraries helps us to calculate each and every time. We can see that by applying the different loss functions we can calculate or minimize the error, and whichever the method is there for that particular application we can take. Okay. So, by this session we came to a conclusion that in different applications we have to use the values for 5 to 6 different kinds of loss functions, and whichever gives the exact or the minimized value we can take that. So, in our subsequent classes we will be knowing about the gradient descendant technology or the terminology, and then the